All right, class. In this video, we continue our discussion of section 6.4 in your note packet on the fundamental theorem of calculus. And so we're picking it up at the top of page 85 with example 3. We have to find the definite integral of x squared plus 1 quantity squared with respect to x from x equals 1 to x equals 5. Before we can evaluate this definite integral, right, we have to square x squared plus 1. And to do that, right, that's just x squared plus 1 times x squared plus 1. And to carry out that multiplication, we just use the FOIL method. And so when we FOIL this, we end up with x to the fourth plus 2x squared plus 1. And now we can evaluate the definite integral. The antiderivative x to the fourth is 1/5 x to the fifth. The antiderivative of 2x squared is 2/3 x cubed. The antiderivative of plus 1 is plus x. And you know, with definite integrals, we can ignore the plus c. And the bar, remember, just reminds us that the lower limit of integration is plus 1. The upper limit of integration is plus 5. So we put in the upper limit of integration plus 5 in for x, and we get this right here. And then we subtract and put in parentheses the lower limit of integration up here for x. And when we replace x with 1, right, we get this down here inside the parentheses. And now it's all arithmetic, and we got to follow order of operations. And so this first term is equal to 625. The second term is equal to 250 thirds. Then we have the plus 5. And then following the order of operations inside the parentheses and distributing the minus sign, we end up with minus 1/5, minus 2/3, minus 1. And then when we find a common denominator and simplify, for the exact answer for a definite integral up here is 10,672/15, which as a decimal is equal to 711.46 with the 6 repeating. So this is the final answer for our definite integral up here. In example 4, we have to find the definite integral from 1 to 4 of x minus 1 times x plus 2. And again, before we can find this definite integral, we have to FOIL x minus 1 times x plus 2, which is equal to x squared plus x minus 2. And now we can evaluate the definite integral. The antiderivative x squared is 1/3 x cubed. Antiderivative x is 1/2 x squared. Antiderivative minus 2 is minus 2x. And again, we can just ignore the plus c. And the limits of integration, the lower limit is 1, the upper limit is 4. So we substitute in the upper limit of integration 4 and for x, and we get this right here. And then we subtract and substitute the lower limit of integration in for x, and we put that inside parentheses so that we distribute the minus sign correctly. This first term simplifies to 64 thirds. The second term is equal to 8. Third term, minus 8. And then when we distribute the minus sign inside the parentheses, we end up with minus 1/3, minus 1/2, plus 2. And then we simplify this, and we end up with 43. This here is equal to 43 halves as an improper fraction, which is equal to 22.5 as a decimal. So our definite integral up here, its exact value is 43 halves or 22.5.